Hello and welcome to another one of the continuous series of maths videos for Bentley Navy tutors. Now I'll be talking about equations and also inequalities, and this video should go through uninterrupted because Jeremy's busy tending to the other people he has trapped in his house. So yeah, there's a fair bit to get through, so it's actually quite convenient. Again, while there is a lot to go through, I'm still going through it pretty briefly, so it's not too long. So I highly recommend you continue to go through your own work and doing your own study as well as watching this, because if you don't watch this, you will fail. Okay, so we'll start with just a bit of a review of equations. So it's stuff that if you are in Year 9, you should already know, but if you aren't in Year 9, if you're in a year below, it's probably a good starting step before watching the rest of the video. So when solving equations, there's a few things you need to know. Firstly, only do one step per line. This will make it a lot easier to keep track of where you're going, and a lot of times you can end up with massive equations which you have to do, which have a lot of lines of working. So doing one step per line means you're not going to get muddled up with where you're going or miss certain things like a double negative or something like that. Also, just for formatting again, as well as not getting confused, make sure your equal signs are lined down the page. Make sure all the well, if you want to start off by writing the actions underneath each line, which is something I still do, make sure that's written clearly, and yeah, write out the question before going into it. So firstly, you just got a few examples of equations, and they're starting pretty easy. So firstly is 5x plus 3 equals 25. So here, first step, minus 3 from both sides, because you're working reverse of BODMAS or PEDMAS or whatever you've learnt. So it's subtraction and addition first is what you do in equations. So yeah, minus the 3. So then you have 5x equals 22, because whatever you do to one side, you have to do to the other side. And then because 5 doesn't clearly go into 22, we'll divide both sides by 5, which will leave us with x equals 22 over 5. There you want to leave it as an improper fraction because that just looks a lot more neat. Okay, so the next example is 3 outside of x plus 2 equals 18. Now, because the 3 and the 18 are multiples, you can just divide 3 from that without expanding it like you will in the next example. So then it becomes x plus 2 equals 6, minus 2 is x equals 4. So again, you can use divisions first if both sides are multiples. And in this example, they were both multiples of 3. The next example is an example of when you can't just divide both sides first. So it's 4 out of x minus 3 equals 15. So yeah, 4 isn't a factor of 15. So you'd have to expand the bracket. So 4x minus 12 equals 15. Then plus 12 from both sides because it's inverse operation. So 4x equals 27, and then x equals 27 over 4. The next one is another tricky one. It's not really tricky, but another step up. So it's 2 outside of x minus 5 equals 3 outside of 6 minus x. So the trick on this one is that both sides have an x, which you do not want. So you have to take the x away from the right side and get it over to the left. So here you'll expand both sides, so it becomes 2x minus 10 equals 18 minus 3. Then you'll plus 3x from the right side to get rid of it, which makes it 5x minus 10 equals 18. Then plus 10 on both sides, 5x equals 28. And then divide by 5, so x equals 28 over 5, leaving that as an improper fraction again. Finally, in this section is fractional equations. So we've got x minus 3 over 2 equals 2x minus 4 over 3. So here you want to get rid of the fraction. So the easiest way to do this is to just find a common common factor. So here it's just 6. So what I would do is I'll take the 3 from the right side and put it outside of x minus 3 on the top left, and then do the opposite with the 2 and the 2x plus 4. So this would leave us with 3 outside of x minus 3 over 6 equals 2 outside of 2x plus 4 over 6. Then we can times 6 from both sides because both of them are divided by 6 with a fraction. So it becomes 3 outside of x minus 3 equals 2 outside of 2x plus 4. And then we can expand that to whatever it is, and then you just work it out as the normal equation. I don't have it written down, and I'm already babbling on a bit like Jeremy. Next we've got the formulae. So this is about substitution and rearrangement. So firstly, with substitution, you might get this, it's likely you'll get this in a test, where there's a question saying something like, using A equals 3, B equals -2, and C equals 5. Evaluate whatever the question is. They're not too hard, but you got to watch out for things like double negatives and like expanding and factorizing. So first example is A minus B times C. So here you do 3 minus -2 times 3 minus -2 times 5. So then you get 3 plus 10 because of the multiplication and the double negative, making it a positive, and then that is 13. These don't really get too much harder except for a few fractions and maybe some powers. So just so yeah, make sure you're making sure you're putting the right numbers in the right spots and stuff like that. The next part is about rearrangement. So the process here is pretty much the opposite of an equation. You want to move stuff from the right to the left and make it more complicated on the left than the right. So the first example is making B the subject in the equation P equals 2L plus 2B. So first we want to get the pronumeral of L out of the way on the right side because we're looking to make B the subject. So we'll minus 2L from both sides, making it P minus 2L equals 2B. Next, we've got to get rid of the 2 on the B side, so we'll divide by 2 on both sides, so it becomes P minus 2L over 2 equals B. Then we can flip that around, and then it becomes B equals P minus 2L over 2, and that is making B the subject. This can get a fair bit harder, so I'll go into a harder one. We've got, make B the subject again in A equals half of A plus B times H. So here we want to times by 2, so we can get rid of the half. So then it becomes 2A equals A plus B times H. And then we'll divide by H because that's outside of the brackets. So we get 2A over H equals A plus B. And then we minus A from that side. So it becomes 2A over H minus A equals B, and then flip that around. So it's B equals 2A over H minus A. And that's really as hard as they get. Sometimes there's a bit harder, but again, it's the same principle of moving everything from one side to the other using the same ideas as there are in equations. Next, and to finish it off, we've got inequalities. So there's 4 inequality symbols. There's less than, which is just the sort of arrow looking thing to the left. Less than or equal to, which is the same with another line on the bottom. Greater than, which is the opposite, and then greater than or equal to, which is the opposite of the second one. When graphing these, you need to have a number plane, as you can see in the top left corner, and you need to have a circle or point which shows the starting number, and then an arrow pointing in which direction it goes into. You need to have an arrow at the end of the direction, and an open circle means that it is not equal to that. But if there is a closed circle on that point, it means it is equal to or greater than or less than. So next we've got testing solutions with inequalities. So firstly, there is x equals 3. Is x equals 3 a solution to the inequality 3x minus 2 is greater than 5? So we want to split this up by doing the left-hand side and substituting the information they've given us into that inequality. So they've told us x equals 3. So on the left-hand side, we've now got 3 times 3 minus 2. So that's 9 minus 2, and that is 7. Quite simply, very hard. Jeremy probably would have got that wrong, but maybe he'll watch this video and he'll get it right next time. And then because 7 is greater than 5, x equals 3 is a solution to the inequality of 3x minus 2 is greater than 5. A bit of a harder one is x equals 7, a solution to the inequality 3 minus 5x is greater than 2 plus 1. So because x equals 7, the left-hand side then becomes 3 minus 5 times 7, which becomes negative 32. And then on the right side, there's also an x, so we have to substitute the 7 in again. So it becomes 2 times 7 plus 1, which equals 15. But because negative 32 is not greater than 15, x plus 7 is not a solution to that inequality. Okay, so the last thing I'll talk about is multiplying and dividing by a negative number. So let's go with the example of 2x plus 1 is greater than 3x minus 5. So you just go through your natural process of minusing 1 from both sides because that's on the left. So 2x is greater than 3x minus 6, and then minus 3x from both sides to get rid of the 3x on the right. So it becomes negative x is greater than negative 6. And then if you were just going through your process, you would then put that over -1, both sides over -1, to get an equal, positive final inequality or equality of x over is greater than 6. However, you can't do this because when multiplying or dividing by a negative number, you need to change the sign and change the direction of the inequality. So what you should be doing there is adding 5 to both sides. So you want to work from the right side over. You'll be adding 5 from both sides, so it becomes 2x plus 6 is greater than 3x, and then take -2, take 2x from both sides, so it becomes 6 is greater than x. And there's a process behind this which the video is too long to really go through. But there's a reason why we can test inequalities, which I talked about before. So if you're unsure, you can, and you have time, just put it through that test and you'll see if you need to change how you did it or not. That's all I'll talk about because I've probably rambled on a bit too much. Hopefully it's not as boring as Jeremy's videos, which go for this long are. But yeah, this is hopefully one of the last maths videos we make. I'm not saying it will be the last because I'm sure there's many more. But yeah, hopefully Jeremy takes a while with his other kids, so I've got a bit of free time. And yeah, keep an eye out for any other videos. Like, subscribe, and yeah, keep an eye out for the next ones.